This is Rich Taylor, Miami University, and the topic of this presentation is filtration, the separation of liquids from solids, typically at the end of a reaction. The objective of this presentation is to distinguish vacuum filtration from gravity filtration, to talk a little bit about filter paper, and then also talk about drying a solvent, the use of drying agents. In the scenario that is typical in the laboratory, you have a lab vessel, either a beaker or an Erlenmeyer flask, with a liquid solution and a solid, and you need to separate the two from one another. The technique you're going to use to do that depends on whether your material of interest is the liquid or the solid in your particular reaction. Oftentimes in lab manuals or experimental sections of papers, they'll say filter, and it is not necessarily clear which technique you use unless you think about the reaction that you're running. If the material you want is the liquid, you're generally going to use what we would call gravity filtration. The most common example of this is that after an extraction or some other technique, you have the product in solution, but the organic solvent is wet. Water is very difficult to get rid of once you've evaporated away the organic solvent, and so you should dry that solvent as best you can before you evaporate the solvent away and actually recover the isolated product. The most typical way to dry a solution is to add an anhydrous salt, most commonly magnesium sulfate, to remove the traces of water, and then you filter the hydrated salt, leaving behind the dry solution with the desired product in it. And so in gravity filtration, you'll have your vessel solution with a solid in it. You're going to pour it into a funnel. Into the funnel is going to be fluted filter paper, so that by gravity the solution will drain into the receiver flask, and then you'll have the solution with the solid gone, and in the case of magnesium sulfate, with also the water removed. Fluting filter paper is an origami-like process, and the purpose of it is to fold the filter paper into the funnel so that it can allow you to filter but not seal the opening of the funnel, which would create bumping. So you want to create little air gaps while you also filter. The easiest way to do that is to fold the paper into an accordion-like shape so that the pleats in the folded paper create an airway. This way you can filter without having little bubbles as air pops through to equalize the pressure. There's a picture of fluted filter paper at the website that's shown below, and you can look at that, but typically you're going to learn how to best fold filter paper as you get into the laboratory. The method they use for isolating the solid in that one is not typically the one that's used in our laboratories. If the solid is the material you want, however, you're going to want to do a vacuum filtration. A vacuum filtration uses a Buchner funnel, a filter flask, typically a water aspirator to create vacuum. What you'll typically do is you'll assemble the apparatus, turn on the vacuum aspirator, do the filtration through the Buchner funnel, wash the isolated solid with some more solvent, and then disconnect the tubing before you turn off the aspirator. If you turn off the aspirator first, sometimes the water going through the aspirator will back up. You don't typically want that to happen. And so here's a mock-up. The drawing's not quite perfect, but what you can see is that there would be filter paper in a Buchner funnel. We have two side arms. You typically only need one, and that's typically on the filter flask. So you're going to be applying vacuum with an aspirator here. You'll have filter paper in your Buchner funnel. You'll deliver a slurry of your solid and a liquid. The liquid will come in here, and your solid will be right here on the filter paper. Some more filtration techniques is on the website that is shown on this particular slide, but there are a couple other items then to make sure of. This is actually an easy process once you get some practice. You need to make sure that the filter paper you use on the Buchner funnel is the right size. You want to cover all of the holes in the Buchner funnel, but you don't want it to fold up along the sides. That creates gaps in your solid will infiltrate around the filter paper and wind up with some of your product in the liquid. You also, once you begin to apply the vacuum with the aspirator, you want to wet the filter paper with some solvent because that's going to help hold it down as you go through. It's also useful that after you're done all of the filtration and washing, that you allow air to flow through and sort of suck through with the aspirator for a little while. That will help with the final drying of the nice pure solvent. With these techniques in mind, and after you do a few filtrations, both of the gravity type and the vacuum type, you're going to find that this is one of the easier parts of the general laboratory